Welcome dear student, Happy New Year 2023. Welcome to my YouTube channel Talking Physics with PR Sarkar. Today we shall learn about atomic structure of electron. तो नए साल के ये पहली वीडियो है, इसमें हम जानेंगे एटॉमिक स्ट्रक्चर ऑफ एटम। ये एटॉमिक स्ट्रक्चर होता क्या है और एटॉमिक स्ट्रक्चर में जो नील्स बोर ने जो पोस्टुलेट दिया था उसको जो मॉडल है, तो अबाउट बोर मॉडल एंड बोर कॉन्सेप्ट एंड ऑल्सो वी नो हाइड्रोजन स्पेक्ट्रा, इट्स मैथमेटिकल डेरिवेशन, द एनर्जी एंड so many things associated with it. And in the next video we shall discuss about some questions related to JEE main and NEET. Okay, so again wish you a very new year and a lots of success in the new year, and let us start with the topic of atomic model. So as you know that various scientists has given their model, such as Rutherford gave, Thomson gave, Thomson model, you know, it is known as pump-Ludwig model. Number 2, Rutherford model. But in this video we cannot go with these two model, because in the previous the Bengali medium students and also the other students know about this model, Thomson model and Rutherford model. But due to difficulties, some Rutherford model, the board comes with a new idea. What is the drawback of Rutherford model? And Rutherford says that when electron revolves in around a nucleus, suppose this is nucleus, when the electron revolves around the nucleus, it emits radiation. So Maxwell says that in his classical electromagnetic theory, he says that when a charged particle accelerates, it emits radiation. Charged particle accelerates, it emits electromagnetic radiation. So if the electron emits radiation continuously, then its losses its energy and its radius start decreasing, and at a time it falls upon the nucleus. So the atom will be unstable. In practice we know that this is not possible because the atoms are not unstable, they are most stable particle, most stable substance. So and number 2 is when the electron moves in a circular orbit, when an electron moves in a circular orbit, their frequency change, as a result their intensity change, their frequency change, and as their frequency change their energy changes, and also wavelength is related to frequency nu. Wavelength is related to frequency. So as the frequency change, therefore the wavelength is continuously change. So the spectrum of hydrogen will be continuous. You can get continuous spectrum. But in practice we do not observe this. In spite of instead of continuous spectrum, we get some discrete line spectrum. So Rutherford model has two drawbacks. One is instability of atom, and otherwise the spectra, the original characteristics of hydrogen spectrum. Now what is the original characteristics of hydrogen spectra? Today we know about hydrogen spectra. So let us do it this. So how hydrogen spectra is different from the visible light spectra? How hydrogen spectra is different? So hydrogen spectra, we can go with hydrogen spectra. When a material is heated, then it emits radiation. Hydrogen or any other particle is heated or in by thermal excitation or any collision, it emits electromagnetic radiation. Now, when a filament, a bulb filament, if a filament of bulb is heated, it emits radiation. If it is heated, it emits radiation, and if we passes the radiation through the prism, we get the components of different wavelength, and if they are focused on a screen, we can get spectrum of different wavelength. Hydrogen is also emits radiation. Hydrogen atom, H atom or H2 atom also emits radiation, and if we passes they through the prism, they also produce spectrum. But what is the difference between visible light spectrum and hydrogen spectrum? What is the difference? क्या अंतर है normal light or hydrogen spectrum? Now it is found that in hydrogen spectrum the wavelength has some specific value, that they are discrete, they does not take any continuous value, such as 656.3 nanometer and 656 nanometer and 634.1 nanometer, 656.3, 634.1, 620.1.2 nanometer and 656.3, 486.1 nanometer, 434.2 nanometer, 4.1 nanometer and 420.2 nanometer. These 4 wavelength are produced only in spectrum in hydrogen. No wavelength between these two values, that is 656 and 486, are emits in the hydrogen spectrum. That is not possible 657 nanometer wavelength in hydrogen spectrum or 489, between 486 or 489 nanometer are not possible. Only some discrete values of wavelength are present in the hydrogen spectrum. So, why this type of discrepancy occur? We read about this. So, and also shows that in the different spectrum of hydrogen, hydrogen shows different series, spectrum series, Lyman, Balmer, and Paschen, Brackett, Front. So, these 5 series are present in the hydrogen spectrum. So, they have certain limiting value. If we draw them in the board, if we draw Lyman series, if we draw Lyman series, if we draw this type is nanometer, that is this is 90 nanometer, 100 nanometer, 110 nanometer, 120 nanometer, then in 90 nanometer the spectrum lines are such type, and then 100, 120 nanometer. Number 2, Balmer series. Bamar is an school teacher in Sweden, and he playing with numbers. One day he playing with numbers, and one day he did not play anything with a number. So he became frustrated and go to his friends and say that please give me some number to play. On that time his friend gives him 4 wavelength. We can say that if this lambda 1, lambda 2, lambda 3, lambda 4, that is 656.3 nanometer in nanometer, 486.2 nanometer, 434.2 nanometer and 420.1 नैनोमीटर, ये 4 वेवलेंथ उसके फ्रेंड ने उसको दिया और बोला कि इस चारों में से इंटर रिलेशन निकल के बताओ. व्हाट इज द रिलेशन बिटवीन देन ही put the famous Balmer series formula, you know, that is 1 by lambda is equal to R 1 by nf square minus 1 by ni square, Rz by 1 by nf square minus 1 by ni square. So if we plot the Balmer series spectrum, Balmer series is from 400 nanometer, 500 nanometer, 600 nanometer, then similar pattern is observed. And if we go with Paston series, we get this type of spectrum. It is not nanometer Paston series, it is micrometer, that is 0.5 micrometer, 1 micrometer, 1.5 micrometer, 2 micrometer, and the spectral lines occur at 1 micrometer and some in 1.5, some in 1.2. From this picture we know that as we grow for the spectral line, as we grow from the lower wavelength side, this side wavelength is small or lower, wavelength is lower. As we grow from higher to lower wavelength size, higher wavelength, then the space between the lines are decrease. देखिए ये कम, इसमें ज़्यादा हो गया और ज़्यादा हो गया, इसमें कम है, इसमें भी कम है, and in certain value, after a certain value, they do not express the express that wavelength. That is, every wavelength must be a certain range. This is called limit series or series limit. This is called series limit. That is for Lyman series, Balmer series, Paston series. This is for Lyman series. We get the light of wavelength that is ultraviolet, UV light. Balmer is visible range, UV light range, visible range, and the all three, that is from Paston to Pfund, we get infrared region, infrared series. Every spectral line has a certain wavelength limit. This limit is called series limit. Okay. So now we can set that two characteristics. We found that not only every continuous value is present in wavelength of hydrogen spectra, and number 2 is as we go from higher wavelength to lower wavelength, the gap or space between the spectral lines becomes narrower or decrease, and for every series there is a certain limit which is called series limit. ठीक है. तो in this way we can read the full spectrum of hydrogen. अगर कोई भी चीज़ समझने में तकलीफ हो तो प्लीज़ राइट इन माई कमेंट बॉक्स, सब्सक्राइब कर दीजिए, और भी अच्छे वीडियो में लाऊंगा इन द फ्यूचर डेज, और अच्छे वीडियो में लाऊंगा. सो नेक्स्ट वी गो for different, finding the different value, that is radius, energy, velocity. Now Bohr, what Bohr said? Bohr said that the atom or electron does not emit radiation when they are in stationary orbit. That does not emit radiation. Stationary orbit means the permitted orbits in which the electron revolve around the nucleus. Electrons does not revolve in any continuous nucleus. Does not revolve in any nucleus. Sorry, it does not revolve in any orbit. Electron does not revolve in any orbit. So, in which the angular momentum, that is mvr, some integral multiple of h divided by 2 pi, only that orbit is called stationary orbit. In which orbit the angular momentum is equal to integral multiple of h cross. H cross means h by 2 pi. And this orbit called stationary orbit. जो ऑर्बिट में, जिस ऑर्बिट में ये रूल सेटिस्फाई हो जाता है, इसको कहते हैं बोर्स क्वांटाइजेशन रूल. अगर ये सेटिस्फाई नहीं हुआ तो इलेक्ट्रॉन उस ऑर्बिट में रिपल्व नहीं करेगा. और n का वैल्यू जो है वो 1, 2, 3, ओनली टेक इंटीजर वैल्यूज, नॉट fractional values, that is 1.5, 2.75 is not considered. So Bohr says that when the electron circulate or revolves around the nucleus, they do not emit radiation. So when they emit radiation? Only when they move a quantum jump. That is, when the electron comes from upper orbit to lower orbit, or lower orbit to upper orbit, only they emits radiation. When they comes from excited energy state to lower energy state, excited means upper, excited to lower, they emits radiation in the form of gamma, emits radiation in the form of photon. Or the reverse process, that is when they goes from lower to higher, that is lower to excited state, they absorb radiation. Okay. So only then they emits radiation, otherwise when they revolve in an orbit, stationary orbit, they does not emit any radiation. And so it is not possible to fall them into the nucleus as per the Rutherford process. And also as they continuously, they do not jump continuously, ऐसे नहीं कि किसी भी वक्त वो जंप कर दे और कंटिन्यूसली जंप कर रहा है, ऐसा नहीं. In some certain condition they only jump when they are excited by thermal agitation or excited by some collision. Only they can make some quantum jump, otherwise they does not jump to lower to excited or excited to lower state. So now we can go with some expression. Bohr said that the orbit of electron is circular. Let us assume the electron revolves in only the circular orbits. So in circular orbits we know the nucleus is at center and electron revolves around the nucleus. So it faces some centrifugal force which is given by mv square by r. Now the electrostatic attraction between electron and nucleus gives this centripetal force. What is the electrostatic attraction? that is Z E square by 4 pi epsilon naught R square. So, from this equation we can evaluate R. What is the value of R? R equal to Z E square divided by 4 pi epsilon naught m v square. R equal to Z E square divided by 4 pi epsilon naught m v square. Now, according to Bohr's quantum condition, we know that the angular momentum must be equal to integral multiple of nh by 2 pi. So, from this we can get the value of R, that is nh upon 2 pi mv. Now, equate equation 1 and 2. Therefore, Z E square divided by 4 pi epsilon naught mv square is equal to nh by twice pi mv. Cancel, v is here and twice pi 2 is cancelled. Therefore, we can get the value of Vn, that is velocity in nth orbit. We can get Z E square by 2 epsilon nh. Z square by 2 epsilon naught nh. This is the value of Vn. So, velocity in nth orbit. Now, that is Vn is equal to Z by n into V1. V1 is the velocity of electron in the first orbit. V1 is given as E square divided by 2 epsilon 0 h, 2 epsilon naught h. E square by 2 epsilon naught h is the velocity of electron in the first orbit. It is written as 1 by 137 of c, that is the velocity of light divided by 1 by 137. These features, that is V1 is known as alpha by c and this is known as c by alpha. Alpha is known as, C alpha, alpha 1 by 137, this figure is called fine structure of electron, fine structure of hydrogen atom, fine structure of hydrogen atom, 1 by 137. That is the ratio of the velocity of electron in the first orbit to the velocity of light in vacuum is called fine structure of atom. So, we can get Vn equal to Z square by 2 epsilon naught nh. Now, put the value of Vn in this equation. That is Vn is proportional to, Vn is inversely proportional to n. Now, we go with the velocity of radius. ये पॉइंट नोट कर लेना, Vn इक्वल टू जेड बाई एन V1. जॉइंट एंट्रेंस में इतना वक्त नहीं मिलेगा कि एक्सप्रेशन याद किया जाए और डेरिवेशन किया जाए, तो इन दैट टाइम वी कैन इजीली make numericals with only this formula. Okay. So, if we put, that is mv Rn equal to nh by upon 2 pi, then if we put the velocity of Vn, that is m into Z E square divided by 2 epsilon naught nh into Rn, that is nh by 2 pi, then Rn equal to, we can get 2 epsilon naught n square h square divided by 2 pi m Z E square. Now, this 2 to cancel, that is Rn equal to epsilon naught n square h square divided by pi m Z E square. Pi m Z E square, that is Rn is proportional to n square by R is proportional to n square. Okay, and this is written as this is written as Rn equal to n square upon z into A0। ये भी जो फॉर्मूला है JEE के लिए बहुत ही इंपॉर्टेंट है और नीट के लिए भी है। ओके, सो व्हाट इज अबाउट A0? A0 इज radius of first orbit of hydrogen atom. A0 is given as, we can know as per see that epsilon naught h square divided by pi m square. Epsilon naught h square divided by pi m square, and this value is 0.529 or approximately 0.53 angstrom. This is the value of the radius of first orbit in an hydrogen atom. This radius is known as Bohr radius. So expression of Bohr radius is epsilon naught h square divided by pi m square. That is, for we can evaluate it from this formula also, that is for first Bohr orbit n equal to 1 and hydrogen z equal to 1, that we can get this value, and the value of Bohr radius is 0.53 angstrom. So now we can go with the expression of energy. Expression of energy is kinetic energy. First we go with kinetic energy, that is half m Vn square or V square. It is, if we put the value of Vn, then we can get the expression of kinetic energy is half into m into Vm. Vm means what we get, Vm equal to half m V equal to V. What is the value of Vm? We can get Vm equal to z square by 2 epsilon 0 Hn. Vm is, the value of Vm is z e square by 2 epsilon 0 Hn square. So half m z square e to the power 4 by 4 epsilon square h square n square. Therefore half and 4, that is m z square e to the power 4 upon 8 epsilon square h square n square. This is the value of kinetic energy. This is the value of kinetic energy. Just put the value of Vn as we derived earlier. This is the value of kinetic energy. Now what is the potential energy? Potential energy is just minus of z square by r, 1 by 4 pi epsilon 0 z square by r, that is m minus of m z square e to the power 4 divided by 4 epsilon square h square n square. This is the value of potential energy. Therefore total energy E equal to kinetic energy plus potential energy, that is m z square e to the power 4 upon 8 epsilon naught square n square h square minus m z square e to the power 4 divided by 4 epsilon square n square h square. So finally we get minus m z square e to the power 4 divided by 8 epsilon naught square h square n square h square h square n square. This is the value of total energy of hydrogen atom. That is En must be equal to z square by n square into E1. What is E1? E1 is the value of hydrogen atom in its ground state. If we put n equal to 1 and z equal to 1, then we can get E1 equal to minus m e to the power 4 divided by 8 epsilon square h square. That is, the value is minus 13.6 eV. This is the ground state energy of hydrogen atom. Minus 13.6 eV is the ground state energy, that is putting n equal to 1. So, in this way we can get the total value of radius, velocity and the total energy. Okay, I hope you understand it. अगर समझ नहीं आया, किसी भी स्टेप में आपको कठिनाई आई तो प्लीज़ पॉज करिए वीडियो को, उसको समझिए और कीजिए. सो हमने फुल डेरिवेशन करके दिखाया है कि वेलोसिटी का वैल्यू क्या होगा और वेलोसिटी का फॉर्मूला क्या है. सो इफ वी गेट द समराइज, देन वी कैन गेट दैट Rn must be equal to z square by n by z square. Rn must be equal to n by z square into R1 or A0. N by z square R1 by A0. Rn equal to n square by z into A0. Vn is equal to z by n into V1 and En must be equal to z square by n square into E1. Okay, so Rn equal to n square by z A0, Vn equal to z by n V1 and En is, that is Rn is proportional to n square. If we take the radius, that is for n equal to 1 R1 or A0 equal to, if we take the ratio of R1 is to R2 is to R3 is to R4, then we can get the value 1 is to 4 is to 9 is to 16. That is, the radius of first orbit and the radius of second orbit is 4 times larger. Radius of third orbit is 9 times larger. Radius of fourth orbit is 16 times larger of Bohr radius. So, what about the velocity? That is Vn is inversely proportional to n. That is, with increasing n, velocity decrease. That is, the speed of electron in the first orbit is mostly speeded electron. That is V1 is to V2, if we get, that is 1 is to half. That is, the velocity would be half. And what about the energy? Energy En, we know that energy En must be equal to, proportional to z square by n square. So, if we go with, and obviously with a negative sign. So, if we take n equal to 1, E1 equal to minus 13.6 eV, E2 equal to minus 3.4 eV, E3 equal to minus 1.5 eV and so on. This is for n equal to 1, n equal to 2, n equal to 3. So, lower energy means the lowest energy state or the closest orbit to the nucleus. As the value increasing with negative sign is actually lower. That is, E1 must be lower, E1 is lower to E2 and E3 is also, E2 is lower than E3. So, the energy of electron closest to the nucleus is lowest. That is, energy 0 means, what is the value of energy is 0? 0 means there is a wide gap, wide distance between the nucleus and the electron. 0 मीन्स बहुत कम है, फोर्स बहुत कम है, वाइड गैप है. So E1, E2, E3 are the energies in the first orbit. E1 is the ground state energy, E2 is first excited, E3 is second excited state. ऐसा नहीं कि E1 फर्स्ट एक्साइटेड, नहीं, E1 ग्राउंड लेवल है, E2 फर्स्ट एक्साइटेड, सेकंड एक्साइटेड स्टेट. So if we draw the energy level diagram, what can we get? एनर्जी लेवल डायग्राम अगर हम this is n equal to 1, n equal to 2, n equal to 2 इससे थोड़ा सा ज़्यादा होगा, बिकॉज इन n equal to 1 एनर्जी E1 मस्ट बी माइनस 13.6 EV. ये कैसे आता है हम नेक्स्ट दिन डिस्कशन करेंगे. जो स्ट्रक्चर और ये जो स्पेक्ट्रा ऑफ हाइड्रोजन एटम का जो डेरिवेशन है वो हम डिटेल्स फुल डिराइव करके जॉइंट और नेट का प्रॉब्लम देखेंगे. देन E2 इक्वल टू माइनस 13.6 माइनस 3.4 EV. सो करीब करीब 4 टाइम्स लोअर है. एंड E3 as the gap is E3 equal to minus 1.5 EV, and then they are closely spaced as we go in the upper level. This is n equal to 3, okay, that is E4 करीब करीब minus 0.84 EV, E4 n equal to 4, E5 equal to minus 0.56 EV, 38 EV, ऐसे होता है. और this is the energy level diagram. And next day we can show with different series. That is when the rays coming from all the levels to 1, that is this 2, 3, 4, 5 से अगर वो ग्राउंड स्पेस में इलेक्ट्रॉन जाम करता है, electron comes from the upper state to the ground state, then a series, we get a series which is called Lyman series, and in this way the corresponding value we can get Balmer series, Bastian series, Beckett-Fund series. So these are the energy level diagram of hydrogen atom. And as we go from ground state to upper level, the energy is increased. This is the lowest energy, that is the energy in the ground state is the lowest, and its value is minus 13.6 EV. And obviously this sign minus means this is the force is attractive force, that is the electron is bound to the nucleus. In many exam it is said that what is the significance of the negative sign? This negative sign means the electron is bound to the nucleus. So I hope आज का वीडियो आपको अच्छा लगा होगा. अगर कोई भी मेरी खामियां नज़र आई कि सर ये समझ नहीं आता, आप थोड़ा स्लो पढ़ाइए, कि आपका कोई भी अगर समझने में नहीं आते हैं तो प्लीज़ कमेंट करिए. अगर अच्छा लगता है तो सब्सक्राइब करिए और ऐसे वीडियो के लिए बेल आइकॉन प्रेस कीजिए. अगेन हैप्पी न्यू ईयर 2023. विश यू ए बेस्ट लाइफ एंड बेस्ट फ्यूचर. थैंक यू.